Hi girls. Today you're going to be watching a video about the second half of section 7.4, higher order derivatives. So far when we've talked about taking the derivative, we've looked at the notation where we have f prime of x or dy dx, and we call that the first derivative of y with respect to x. So sometimes we want to take and find the derivative of the first derivative. It says here, find the gradient of the first derivative. Find the slope of the line at a point on the first derivative. And later on, we'll do some graphing of this and take a look at what that looks like. But if you take the derivative of the first derivative, that's known as the second derivative. Again, of y with respect to x. And the notation for that looks like this. We use the f double prime of x for the f notation. The dy dx notation changes a little bit. Now pay close attention. It's d squared y with respect or over dx squared. Okay, so it's a little bit different. The squaring is on the d in the numerator and on the x in the denominator, not on the y. So you can keep taking the derivative of other derivatives. So you could take the third derivative of y with respect to x. We'd write that as f triple prime of x, or d to the third y over dx to the third. Okay? So we call all of these higher order derivatives. There's the first derivative, and then everything else is lumped into the category of higher order derivatives. So we're just going to do a few examples today, and then you can work as a class on doing exercise 7M. Now I did get some emails talking about the homework from Thursday night that you were struggling with, and I want you to work as a group today after you take your assessment on some of those problems too, if you need to. I wanted to remind you that if you go to Edmodo, look at in folders for chapter 7, there is the file where I've uploaded the worked out solutions. So take a look at that. So instead of just looking at the solutions in the back of the book, look at the worked out solutions, and that will show you how the derivatives were taken of each one and how the chain rule was applied, or the quotient rule or the product rule. So take a look at that PDF that is posted in folders under chapter 7 on Edmodo. And then we'll talk more about this on Monday too when I get back. Okay, so the first one, our first example, says find the first three derivatives of f of x is equal to x to the fourth plus 3x squared plus x. So let's take a look at this. So we're doing A, and we need to find the first three derivatives. So our function is f of x is equal to x to the fourth plus 3x squared plus x. So fortunately, this is a polynomial. We can use the power rule. This is the easiest way to take a derivative. So f prime of x, using the power rule, would be 4x to the third plus 3 times 2, 6x plus 1. Let's take the second derivative. Again, we have a polynomial. This one's easy. So 12x squared plus 6. And then lastly, the third derivative. F with 3 primes gives us 24x. And that's it. That's our answer for A. All right. Let's take a look at B. So in this case, B says if the first derivative is the square root of x squared plus 4, find the second derivative, f double prime of x. So we're going to need to use the chain rule here. We have two functions going on. We have the square root function and then the function that's on the inside. So the square root is the outer function, x squared plus 4 is our inner function. So I'm just going to rewrite f prime of x as x squared plus 4 to the 1/2. It makes it easier to work with. Now my outer function, u of x, is the square rooting function. I change my inner function just to be f. My inner function is x squared plus 4. So now I'm going to take the derivative of my outer function. So u prime of x is going to be 1/2 x raised to the negative 1/2. And now I'll take the derivative of my inside function, which will be 2x. So now I can take the second derivative, f double prime of x. I look at what my derivative for my outer function is, so I know I have a 1/2, then whatever it was that my inner function was, taken to the negative 1/2. My inner function is x squared plus 4, and then I multiply this times the derivative of the outer function, 2x. So now all I have to do is simplify. 1/2, these are all being multiplied, girls, and this is where some of your simplification gets confused. Every single thing, this is being multiplied by this, which is being multiplied by this, which means I multiply numbers to numbers. So 1/2 times 2, that equals 1. So I'm left with x, remember, variables come first, then all the goofy looking stuff, x squared plus 4 raised to the negative 1/2. We cannot leave it in unsimplified form with a negative exponent. So that means x remains in my numerator, and in my denominator I bring down the x squared plus 4 and change it to a positive 1/2. If you want, you can change it back then to radical form. You do not have to change it back to radical form. Either one of these answers is acceptable. All right. Let's look at problem C. All right, so this one is in the Leibniz notation. We've started with y, so when we start with f of x, we continue on with the f prime notation. This one says y is equal to 4 times e to the 2x, so that means we're going to use the dy dx notation. This is y. This is asking us to find the third derivative, d to the third of x over dx to the third, and then we're going to evaluate it, that's why this is here, at x equals 1. So this one's going to take us a little while. Let me give myself some room. Let's start with C. So my function is y equals 4e raised to the 2x. I have e as one of my functions, and then the 2x as one of my functions. So my outer function, u of x, is my e to the x function. My inner function, v of x, is what's going on in my exponent here, 2x. So my prime, or my derivative of u, e to the x is e to the x, that's easy. And the prime of x is just 2. So I can take my first derivative, and I need to use that derivative notation. So it's going to be dy over dx. Don't forget we have this constant in front here now. And when we learn the constant rule, if you have a constant times a function, it's in the end you take the derivative of the function and multiply it by the constant. So the constant stays there. So 4 e to the 2x, my derivative is e to the x, and we replaced the x back with the original 2x, times the derivative of our inner function. So times 2. So I have numbers here. So 4 times 2, 8 e to the 2x. All right. Now I need to take the second derivative of 8e to the 2x. So we're going to start here again. Our u function is e to the x. So our u prime, again, is e to the x. Our v function here is, again, what's in the exponent? 2x. V prime x, again, is 2. So now I can use these to take my second derivative. So d squared of y over dx squared equals my, now my constant this time is 8, so the constant stays there. E to the x, but I replace my inner function, 2x times the derivative of v, 2. So now I've got 16 e to the 2x. I have to take the derivative now of 16 e to the 2x. Let me move up here. So this time, my inner function, let me write this back up here. I'm at 16 e to the 2x. My outer function, again, is e to the x, so its derivative, e to the x. My v function, again, is 2x, so the derivative, again, is 2. So this time I'm taking the third derivative with respect to y of dx to the third. My constant this time is 16. The derivative is e to the x. I replace it with my inner function multiplied by the derivative of my of my inner function is 2. So the answer, the final answer, the third derivative in this case is 32 e to the 2x. Now, let's look back at the question. It was asking us to evaluate this, we put this long line here, when x equals 1. So now we're going to evaluate this. 32 times e to the 2, and we replace x with 1. So our answer is 32 e squared. We don't need to calculate what e squared is. That is our third derivative. All right. And the last one is a piece of cake. All right. So now we have two different looking variables, s and t, and when we have variables other than x and y, we definitely need to use the Leibniz notation. So in this case, we're taking the derivative of s with respect to t. And I need to find the second derivative. So our function is s of t equals negative 16t squared plus 16t plus 32. So we get to use the power rule again. It's just a nice polynomial for us. So in this case, it's going to be the first derivative, d of s, over d of t. Use my power rule. This is going to give me negative 32t plus 16. I have to take the derivative of my first derivative, so that's d squared of s with respect to, or over dt squared, which gives me, using the power rule for a polynomial, negative 32. And that's it. So all you're doing is taking the rules that you've been using and applying them to find additional derivatives, higher order derivatives. There we go. All right. So you can work as a group now on 7M. You can go back and do some of the problems that were from yesterday. 7M, finish that for homework. It's 1 through 6, and then there's more answers. So 1 through 10, 7M for homework, and we'll go over all of this on Monday. Enjoy your weekend, girls.